There is a surprising amount of power trapped in your adventure motorcycle. Your bike's potential has been intentionally restricted by the manufacturer. Fortunately, using modern electronics, we can easily transform the way your machine performs. Welcome to MOTOTREK. My name is Mike Spurgin. Your motorcycle is the result of the compromise and negotiations between 3 players in the production pipeline. The engineering department wanted to deliver a motorcycle that was amazing, exciting, fun, race-ready. In sales and marketing, they were after a motorcycle that was safe, reliable, something sensible, had broad appeal. And then the regulatory agency, they needed to have a motorcycle delivered that was quiet and efficient.
The indication is that someday they will give us 300 miles to the gallon.
So we've got 3 cooks in the kitchen that are baking up a bland moto casserole. But luckily, we don't have to settle on this mediocre performance. We've got some magic black boxes that will boost the performance of any adventure motorcycle. So to understand this new technology, let's take a look back at the humble carburetor.
We just came through the needle valve that lets the gasoline into the carburetor. That is the float on top of the gasoline.
The carburetor. Look at this thing. It's a mechanical marvel. Since 1888, these have been on internal combustion engines. Everything, motorcycles for 100 years. We had a carburetor on our bike. These are fuel metering devices that bring the air-fuel mixture into the engine. Some of these components are just incredible in their complexity and intricacy. So many of these parts need to work together in this little harmony for the engine to run. And you can see how many points of failure there are. You've got all these screws and O-rings and diaphragms. If there was a vacuum leak in any one of these or a fuel leak, you could have major problems that could leave you stranded. So the carburetor, being this really beautiful piece of equipment, is also very flawed in the fact that it's so mechanically complex. Fortunately, we don't have to use this 100-year-old technology to fuel our bikes anymore. From the complexity of the carburetor in Grandpa's bike now to something much more streamlined and effective, we have this fuel injector and throttle body. This is what's replaced it. We're using now digital signals and electrical impulses to inject fuel into our engine instead of using vacuums and ports and orifices. On the side of our throttle body is a potentiometer known as a TPS, and the TPS is reading the position of the butterflies. The voltage output of the throttle position sensor is used by the computer to make a determination about how much air is flowing through the throttle body. As you pull back on the grip and this opens up, that voltage changes. And so as you rip the grip, that tells the computer how much fuel to send to the injector. The fuel injector is a very simple electromechanical valve. Gasoline is presented on this side under pressure, and then the outlet nozzle is over here. Inside of here is an on and off valve, and the ECU is commanding this on and off hundreds of times a minute. So based on where you are in the throttle and the RPM range, the map inside of the ECU then outputs all of that information to the spark plug and to the injector to run your bike. Your stock motorcycle came with an ECU that was programmed by the manufacturer, and looking over his shoulder was a regulator from whatever country your bike was designed for. And so all the values for fueling, ignition, all of those things are preset. They're locked. They're locked into this ECU, and it's not user configurable. You can't change any of these data points. So if you do anything to your bike, like add a pipe, change the exhaust, do anything with the intake, you're going to need to change fueling. Remember back in the carburetor days when you would do that, you would have to change jetting? Well, we need to do that exact same thing now with our fuel-injected bikes. These are piggyback fuel tuners. These are little magic boxes. Basically what these guys do is they're going to increase the pulse width of the injector. So when we plug this into the system, this is going to increase dynamically the amount of fuel that the injector gets from the computer. So we're just adding or taking away pulse width from the duty cycle of the system. So back in the day when we would do that on a carburetor, we would just increase jet sizes or needle clip or do all those mechanical things. We're now doing it electronically, zeros and ones. That's how we're adjusting carburetors now, through these fuel injection tuners. Now there's another option, and that is just to reflash the map that's inside this ECU. And so that's some voodoo magic that there are guys out there who have the capability and the technology and the understanding to plug this into certain computers, certain systems, and then go into the map data, the firmware, the software of how your bike runs, and then make adjustments and calibration changes so that you can accommodate those exhaust pipe or intake mods that you might make. The guys who do this are very specialized, very trained. There are some software locks that are on these, built into these to prevent that, but there's some clever guys who have found workarounds to do that. It's also important to note that any changes that you make to any of these systems, really, the intake or exhaust or the fueling, may be a violation of some of the emission codes and laws and standards in your part of the world. So be very aware that these changes may put your bike into a category of off-road or competition use only. So now we come to the holy grail of engine tuning, and that's to replace out our stock ECU with an aftermarket. And there's some real strong advantages to doing this. I've got a couple here. This one over here again is that stock ECU. These other two, these are aftermarket ones made by Vortex out of Australia, and then this is Get, Athena Get, they're out of Italy. And so there are many manufacturers that make these for many different types of bikes. These are for KTM, the half-liter dirt bikes. Some of the advantages of going with an aftermarket ECU over the stock ECU are things like processor speed. These just run on a faster chip. They also have increased capabilities. For example, some of these have traction control that's variable, that's data processed. So here you've got this little black button. This is a barometric pressure sensor, and so that's just essentially like an altitude compensation device. And then these are interesting. You've got these little pigtails. For example, this one allows you to run a second injector. That is a very unique feature. If you're going to build a race bike, you're going to need extra fuel because of the increased horsepower demand. And then these other two, one of these will go to the programming, and we can plug this into the laptop and check all kinds of telemetry out of this and do all kinds of high-value programming features. And the other one lets us plug into things like map switches and traction control knobs. You know, one of the things I like to say about maps is that's really like describing the personality of your bike. If you want a bike that's very hard-hitting and aggressive, that's a personality. If you want one that's more docile, soft-hitting, more linear performance for trails and off-road riding, that's a personality. And so these aftermarket ECUs give you the ability to almost customize the power output that you may want for your bike. And a box like this will let you do all those customizations where you're not going to get that out of the stock ECU, or even like the stock ECU with the fuel tuner. There's just so many extra features and benefits to having one of these ECUs. Now, all of these features come at a cost. These are pretty expensive. This particular one's $900 retail, and the other one is $700 retail. So these are not for the faint of heart. This is really for somebody who's trying to push the envelope as far as tuning, performance, capability of their bike, maximize the horsepower. These aren't for everybody. You may be on a bike that you just already feel is powerful enough. You just want to maybe clean up the fueling. Maybe that fuel tuner is a good way to go. But if you're looking for something that's racy and at the extreme end of the spectrum, or like I said, what the race department of the manufacturer is really hoping to deliver, that the, say, marketing department took away or the regulatory agencies stripped out, having one of these on your bike opens the door for all that horsepower and all those possibilities. Before you modify your fuel system, make sure that that TPS sensor is in spec. You can do that very easily and simply with a throttle position harness and a meter. It's that simple. You're on an adventure bike. You're not doing flat tracking, stoplight wheelies, or racing. So why should you care about making any modifications to your fuel system? Almost without exception, every machine is underfueled from the factory by design. With corrected fueling, you get smoother throttle response, safer power, and better engine reliability. A lean burn makes the engine run hotter and could create engine durability problems. A rich fueling condition creates sluggish power, poor fuel economy, and could potentially wash the engine oil out of the crosshatches of the cylinder. The optimal fuel ratio is 14.7 to 1, stoichiometric. That's what we're after, and that'll give us the best balance between power and durability. You and your bike will both be happier if your air, fuel, and ignition ratios are correct and optimized.
Gasoline is powerful, but each drop can give a 100% account of himself only when he finds the most efficiently designed gasoline system to help him along his journey. For a successful life, every drop of gasoline depends entirely upon what happens to him after he gets in the swim. Ah, a nice one.